Hey everybody, my name is Jason, and this is a demonstration of version 1.2 alpha of Blawx, a web-based tool for rules as code. In this video, I'm going to show you how we generate the demonstration rock, paper, scissors act that's included with the software, and how we use that in coding. And then I'm going to show you some of the new features that came in version 1.2. So to start, we have a workspace here with the rock, paper, scissors act created, and we are just going to go section by section through this act and add code for each section, and then create some tests and see what we can make it do. So section 1 says a game of rock, paper, scissors has 2 players. So Blawx doesn't know anything about anything. When you start, right here, there are no known categories, there are no known objects, and there are no known attributes. And those are the things that you are going to use when coding rules. So before you can get to the rules, you have to describe the ontology. You have to describe a vocabulary to Blawx and tell it what words you want to be able to use. So here, we know that we want to be able to use the words game and player. Those are categories of things that we want to talk about. So we're going to say, we know that game is a category. Copy and paste that. And we know that player is a category. And it also gives us here a relationship between these 2 categories. Games have players. So we're going to explain that to Blawx as well by saying a game, which is now a known category, has the attribute, and we'll call it participant. And a participant is a player. We save that. Now, once we've saved that, there's now a known attribute. Game's participant is player. That's not the best language that we could possibly have for that block, and it's also not how we would want this to show up in explanations. So Blawx lets you customize how this will be described in natural language. So we're going to switch the order. Instead of game then player, we're going to do player then game. And we're going to say the player played in the game. Now, if we go in here, you can see the text has been changed. So that's section 1. Let's move on to section 2. There are 3 signs: rock, paper, and scissors. So again, in terms of vocabulary, we need to describe the word signs. So we're going to say, we know that there is a category that we will call sign. And that's all we need in the root of section 2. Let's go to section 2a. We need to say that there is a specific sign called rock. Now that we've created the known category of sign, we can also go into the objects drawer, and we have the ability to create one. So we can say, we know rock is a sign. And we can copy this outside block, the we know block, and that will copy the things that are inside it as well. And then we can go into paper, paste it, and change the text. And we could go into section 2c, paste it, and change the text to scissors. Save those. Rock, paper, and scissors are all now known objects in our database that we can use to say other things. Section 3. The signs are related in the following ways, and it says how each sign beats each other sign. Now, we could define the word beats the first time it appears in section 3a, but it's a little cleaner to put it in section 3, so we'll do it here. We're going to say, we know that a sign has an attribute which we will call beats, and relates to another sign. So one sign beats another sign. Now, again, we can save that. Blank's beats is blank is not a very intuitive way of describing that, so we will customize and just change the text to beats. Blank beats blank. Much better. So now that we've created the relationship of one sign to another called beats, we have the vocabulary that we need to encode sections 3a, b, and c. To say rock beats scissors, we just say, we know rock beats scissors. And then again, we can copy this outside block and paste it to create the other two rules, which are scissors beats paper and paper beats rock. There you have it. Section 3 is encoded. Now we get to section 4. And section 4 says the winner of a game is the player who throws a sign that beats the sign of the other player. So there are two things here. There's definitely a rule that we're going to have to encode, but there's also two relationships here that we haven't explained to Blawx yet. Blawx does not yet have a way of saying that someone won a game. And it also does not yet have a way of saying that someone threw a sign. Those aren't words that we've described to Blawx yet. So we're going to start by creating those two attributes. So we're going to say a game has an attribute that we will call winner. And the winner is a player. And a player has an attribute called throw, which is a sign. So now we've created those relationships and we have some blocks. Again, the text isn't exactly what we'd like, so let's customize it. It makes the coding easier and it makes the explanations clearer. So we're going to say player 1 game. So we'll reverse the order, change the text to 1. And we're going to say player through sign. So we don't need to change the order. We just change the text to through. And if we save that, we see we have some very clear attribute blocks that we can use to describe the rule, which is the next thing that we need to look at. So let's collapse this, make a little room for ourselves. Now the rule is the winner of a game is the player who throws a sign that beats the sign of the other player. Now this is where you get into formalization, and there's nothing we can really do about it. Formalization is hard. So what you have to do is you have to change this statement into the language that Blawx has available to it. And when we do that, we end up with something like this. We say, first we grab a rule block. When we know this, we also know this. So when we know that two people played in the same game. So we're going to say that by having two played in blocks. And we're going to use the same variable game in both of them. So that Blawx knows we're talking about the same game. And then we're going to create differently named variables. One called player 1 and the other called player 2. So if we know that these two people played in a game, and if we know what they threw, so we need to grab our through block, and we're going to grab two of those. We're going to say player 1 and player 2 both threw something. We don't know what. This is in the abstract, so we're going to say throw 1 and throw 2. And then, most importantly, throw 1 needs to beat throw 2. So we grab our beats block and we say throw 1 beats throw 2. So these are the conditions. This is how you formalize the conditions for this rule in Blawx. Player 1 played in game, player 2 played in game, player 1 threw throw 1, player 2 threw throw 2, throw 1 beats throw 2. And then what do we know when all of those are true? Well, we know that player 1 won the game. Oops, that's not what we needed. And there you have it. That's the encoding of the rock, paper, scissors act in Blawx. Now that we have our encoding, what can we do with it? Well, we can ask questions. We can create fact scenarios and ask questions. So let's do that. Let's create a test. We're going to create our Bob-Jane test. And here what we're going to do is we're going to create some concrete facts. We're going to describe a game, and we're going to ask it who won the game. So we're going to say, first of all, that there are, well, let's first say that there is a game. So there's a game, and it's called test game. Now we're going to say that there are 2 players. So we'll grab this player creation. Bob is a player. Copy and paste that. Change the text to Jane. Jane is a player. And as we save those, Bob and Jane are now in our known objects. So now we want to say that Bob and Jane played in test game, because Blawx doesn't know that yet. So we grab our played in. We grab test game. We can copy and paste that to do 2 of them. Now we throw Bob in there and Jane in there. So now in this fact scenario, Bob and Jane both played in test game. Now we need to know what they threw. So we grab 2 throw blocks, copy Bob in there, copy Jane in there, and we can say Bob threw scissors and Jane threw rock. Now that's our fact scenario for this test game described. Now we need a question. What do we want to know? We want to know whether or not Jane is the winner. So let's ask, is it true that Jane won test game? And we can open up our results screen here, save that code and run it. And it says Jane did win test game, and it gives you the reason why, and it gives it in the natural language that you used to describe those relationships. Jane played in test game, Bob played in test game, Jane threw rock, Bob threw scissors, and rock beats scissors. So it gives you an answer, and it gives you an explanation. But here we were asking a yes or no question. Is it true that this concrete question is accurate? We can also use variables in the question and ask Blawx to do a search. So we can say, is it true that anyone won test game? And if we save that and run that, the answer comes back, yes, it is true, because anyone could be Jane. Had there been more than one winner of the game, we would get more than one model here. So that's how we can use our encoding to create questions and apply facts and have the rules calculate the answer to our question. Now, what we would like is to be able to use this in other applications. We would like for our Blawx code to be available to other applications to power the legal conclusions that are being drawn in those other applications. So the great thing is that once you have created this test, you have already created an API endpoint that is capable of answering the same question in the same way. All you have to do is add the word run to the end of your URL, and you are now at the API endpoint. We can post it, and you get a JSON version of the answer that was just displayed on the screen with all of the explanation in English. But this can be used by software to do the exact same thing that you're doing in the code. So this is using facts and applying them to the rules in order to find a legal conclusion. What if we wanted to go the other way? What if we were interested in knowing, in the abstract, how might a person win a game of rock, paper, scissors? Blawx lets you do that too. So we can create a new test, which we will call hypothetical. And instead of creating facts that we know, we're going to create assumptions. We are going to ask it to assume that there are players in games. And we're going to ask it to assume that players threw signs. And then with those two assumptions, we're going to ask it, is it possible that anyone won any games? Now we can save this, and this is like asking, how might someone win a game of rock, paper, scissors? And intuitively, you know that there's three possible ways. So if we ask that question to Blawx, you'll see we get three answers. The first answer is the answer where player 1 plays rock and player 2 plays scissors. The second, scissors beats paper. And the third, paper beats rock. So not only can Blawx be used to apply facts to a rule in order to get legal conclusions, it can also be used to apply a legal conclusion to rules in order to generate facts. The logic goes in both directions. And again, this test is zero-click deployed as an API. And you can ask the same question from any piece of software anywhere in the world. So that's the coding environment. What have we changed? Well, rules as code is often used in drafting processes. And in a drafting process, it's not good enough to just be able to change your code. You also need to be able to change the law. In prior versions of Blawx, you couldn't edit the Akoma Ntoso document that describes the legislation after it had been put in, and we wanted to fix that. So we created a plain text programming language called Clean that is used to generate Akoma Ntoso encodings of legislation based on a markdown-like syntax, a plain text syntax that then gets converted into legal.ml in the background. So if we want to change the rock, paper, scissors act to the rock, paper, scissors, lizard, Spock act, we can now do that. We can go into the rule editor. Let's change the title to rock, paper, scissors, lizard, Spock. Section 1, a game of rock, paper, scissors, lizard, Spock has 2 players. And in this game, there are 5 signs. Rock, paper, scissors, lizard, Spock. Now this reads just like text, which is the great thing about the clean format, is that it's very intuitive to read and very easy to write. So you can edit the legislation in this way, save it, and you can see now we have our new act with the text that we put in. And if you actually inspect this code, you can see that it's actually an Akoma Ntoso document that's being displayed inside the page. So it's generating Akoma Ntoso in the background. You can now go into your code editor and the new sections of your act appear. No code yet. So let's grab this block from scissors. We can add it to lizard. Save that. And we can add it to Spock. And save that. So that's the new thing in Blawx version 1.2. We now have a really user-friendly way of editing the legislation and editing your code to match. So it's not just the code that's changing, the legislation can change too. Thanks very much for watching. If you're interested in learning more, I am at Roundtable Law on Twitter, and I'd love to hear from you.